Good day to all of you. Today we shall study how to construct a binary tree when pre-order, in-order and post-order. Out of these three, any two sequences are given. This is part 2 video. In first part, I have covered if pre-order and in-order travel sequences are given, how to construct a binary tree. And in this video, I am covering how to construct a binary tree if in-order and post-order travel sequences are given. Our sincere thanks and acknowledgement to authors Ellis Horowitz, Sarta Sani and Susan Anderson Fried, authors of the textbook Fundamentals of Data Structures in C. We shall take up problem 2. Problem 1 I have covered in video 1 where pre-order and in-order sequences were given. In this video, post-order and in-order sequences are given. We shall learn how to construct a binary tree. Here first we have to decide which is the root. For that we'll have to observe post order sequence. In post order sequence which comes last, that is the root. Hence A is the root. Then if we draw a root here, which is left side and which is right side. For that we have to observe in order. So here root comes in the middle. So here in order sequence, if you take up A is here, this side forms left subtree and this side forms right subtree. So if A is the root, D, B, F, E do come on left side and G, C, L, J, H do come on right side of A. That is this group here, this group here. In this, which is the root? For that we'll have to observe post order sequence which comes last among D, B, F, E. So among D, B, F, E, here B is coming last. D, F, E first, last is B. That will be the root. Hence, here we draw B as root. The remaining will be D, F, E. So B root is drawn. It is the left child. The remaining here are D, F, E. Among these, if B is the root, which is left child, for that we'll have to observe in order sequence. If B is the root, left side. If B is the root, left side we have D. So D will be the left child. Remaining here F, E will become right side of B node. So D is made as left child. It is connected to B. So among FE, which is the root? So which is the root means always we'll have to consider post order. So FE, which comes last here, E comes last in post order sequence. Hence E is the root here. E is made as the root. It is the right child of B. Then what is remaining? F is remaining. So if E is the root, F is remaining. Is it right child or left child of E? So for that observe in order sequence. There locate E. So left side we have F. Hence F comes left side of E. It will be the left child of E. So F node is taken. It is made as left child of E. Now we have constructed this left subtree of A. Next we'll move on to right side. Among these, which is the root? For that we'll have to observe post order sequence which comes last. G, C, L, J, H, K. C comes last here. Hence C is made the root here. The remaining G, L, J, H, K, they will be remaining. So C is made as root. It is connected as right child of A. In this, which are remaining? G, L, J, H, K. So which are the left child and which are the right child of C now? For that we'll have to observe in order sequence. Locate C, L, J, H, K right side. Then only G is the left child. So G will be here. L, J, H, K will be drawn right side. So G node is taken and L, J, H, K are written on right side. So G node is connected as left child of C. Next in this, which is the root? L, J, H, K. Observe post order. Which comes last here? L, J, K, H. So H is the last. So H is made as the root. That is connected as right child of C. Which are remaining here? If H is the root, L, J, K are remaining. So what they form? Left child or right child? Which one is left? Which one is right? For that we'll have to observe in order sequence. Search for H as root here. K is coming right side. If H is the root, right side K. So here K becomes right side and L and J become on left side. So L, J left side, K is the right side, K node is taken, it is made as right child of H. Now in LJ, which is the root, to find root always go to post order. LJ here, which is coming last, J is coming last. So J will be the root. So J is made as root, it is the left child of H. Now in this, if J is the root, what is L? Is it left child or right child? For that we'll have to observe in order sequence, locate J. So there L is on left side. So if J is root, left side we have L. So L becomes left child of J. L is node is taken, it is made as left child of J. Now binary tree construction for the given post order and in order sequences is over. This is how we can construct a binary tree if these two travel sequences are given. Which is the root to find? We'll have to observe post order sequence. Around its left and right, which nodes do come, for that we'll have to observe in order sequence. This procedure is to be done recursively. This is how the binary tree is drawn. I hope you understood. Thank you. Now to verify whether our answer is correct or no, for the drawn binary tree we'll have to do post order traversal and in order traversal, and those sequences we have to observe. If they are same as the given, then our answer is correct. So verifying the procedure I have discussed in one of my previous videos, that is tree traversals. Means if binary tree given, how to get pre-order, in-order and post-order sequences you can. Here binary tree is constructed. For that, following the procedure, first let us find out what is post-order sequence. So from starting point in this yellow direction, if we move, where is cutting this green right arrows? So it is cutting first D, then F, then in this direction E, then B. So then if we move in this direction, then it is cutting G. If you move in this direction, it is cutting G. If you continue, it is cutting L, then J, so then K, so H, C, lastly A. So if you note down the post order sequence, just now we noted while cutting green right arrows, it is D, F, E, B, G, L, J, K, H, C, A, which is same as the given one here. Next we shall find out in order sequence. So for in order sequence, the path of movement is same, but this time we'll have to consider down arrow for each node. This procedure I have already covered, you can refer to my previous video. So starting from S point, start point, if you move in this direction, first D is cut, then B, then F, then E, so continue A, then G, C, so it is cutting down arrow here, L, then J, then down arrow of H, then K. So then going back to finish point. Then if you note down what we have gone through post order sequence, we got D, B, F, E, A, G, C, L, J, H, K. Hence whatever binary tree we have found out in problem 2, where post order and in order sequences are given, that is correct. Okay. I hope you understood. Thank you.